Hello all, welcome to my YouTube channel. Today we'll start with the next chapter, which is general principle and processes of isolation of elements. So, out of 117 elements known so far, noble metals, noble gases, N2, O2 and few others are available in native state, while others are available as their compound. All of these are useful to us in one or the other form. Iron is present in hemoglobin, zinc, as you know, it is present in insulin, and cobalt is present in vitamin B12. Similarly, magnesium, as you all know, it's present in chlorophyll. Aluminium is used in making transmission cable, utensils also. Copper Copper is used in making electrical appliances and in increasing hardness of gold. In making many alloys also, the copper is used. Zinc as you all know, it is used in making electronic gadgets. It is used in galvanometer, extraction of gold and silver also. Iron is extensively used as wrought iron, cast iron, steel, alloy steel for making articles of day to day needs. This unit mainly deals with the extraction of iron, zinc, copper, aluminium, and many other metals and also their purification. So, let us discuss about the occurrence of the metal. Metals generally occur in the form of their oxides, sulfides, carbonates, sulfates, halides, etc. Principal minerals of some metals are listed. As you can see on the screen, aluminium, zinc, silver, iron and copper. Now, out of all these ore, the important one is already highlighted with a star. Bauxite, hematite for iron, then copper pyrite, which is also called fool's gold, is the important ore of copper. And from the zinc side, zinc blende is there, and argentite, or we can say silver glance. Now let us see how this ore actually looks like. Now, as you can see, iron ore, which is hematite. Okay, this is iron ore, hematite. And what's the formula for this? Fe2O3. Copper pyrite, as you can see on your screen, this one is copper pyrite, and the formula for this is CuFeS2. And next is aluminium, means ore of aluminium, which is bauxite, and this reddish ore is bauxite. So now what's the formula for bauxite? This is important. This is actually asked in many exam. Al2O3 dot 2H2O. This is the formula for bauxite, and bauxite is an ore of aluminium. And last but not the least is zinc blende. As you can see here, this bluish color ore is called zinc blende. And it's why it is called zinc blende, because if any metal is forming sulfide ore, then such ores are called blend. So as this is the ore of zinc, so this is called zinc blende or zinc sulfide. Now coming to the next is extraction of metals and non-metals. Okay, this is something which is very important because different metals and non-metals are extracted, right? Now, different non-metals are extracted by de-electronation using different processes, and metals are extracted by electronation using certain definite methods as mentioned here one by one. Okay, so let us discuss all these methods. The first method is pulverization. Now, what is pulverization? As you can see here, a machine which is called a pulverizing machine. Now, what's the use of this pulverizing machine? The lumps of the ore, the hard, as you can see, this hard ores, lumps like this, big ores, the lumps of ore are converted into, as you can see here, are converted into small pieces by using jaw crusher and to powder by employing stamp mill or ball mill. So this is basically used to convert any big lumps of ore into the small pieces. I hope till this everything is clear. Now coming to the next, which is important and has been asked many times in the exams, which is magnetic separation. Now this method is employed to separate the magnetic and non-magnetic components present in the ore by carrying the powdered ore on a conveyor belt. Can you see this belt? This belt is called conveyor belt. Conveyor belt passing over an electromagnetic roller. As you can see, this magnetic roller. Okay, this is an electromagnetic roller. So the non-magnetic part is thrown away. As you can see, this is the non-magnetic part and this is the magnetic part. So the non-magnetic part are thrown away while the magnetic part is, as you can see, it's coming down here. So the magnetic part makes a heap below the magnetate. Now for example, I can take the example of this FeWO4. Now what is this? This is an important ore of iron which is called wolframite. Wolframite. I am writing the spelling again. Wolframite. Okay, and the formula for this is FeWO4. So magnetic impurities of this wolframite is separated from tin stone by using this method. Now other cases are chromite ore. I can write the ore here. Chromite ore, which is FeO.Cr2O3, and magnetite also, which is Fe3O4. Okay, so all these impurities can be separated by using this magnetic separation method. Now coming to the next method is hydraulic washing. Now this hydraulic washing method is also called gravity separation method. Is it also called gravity separation method? Now this method is employed to purify heavier ore such as oxides. Now oxides are heavier ore. Example I can give you hematite, tin stone, etc. And carbonates also, like calamine, and many more examples of carbonate ore are there. And native gold, which is again a heavy ore. Okay, so as the ore is, what happen in this method is the ore is washed with the running water. As you can see here, this is a crushed ore, and it is getting washed by the running water using big tubs or Wiley table that has grooves. That has grooves. Can you see grooves? Yes, the lighter impurities are washed away and the heavier impurities or the heavier particle of the ore settle down. Okay, so this was all about the hydraulic washing. The second name of this method is gravity separation method, because in this the ore is washed with the running water using a big tub, and the lighter impurities are washed away and the heavier particles of the ore, they settle down at the bottom. Now coming to the next method is the froth flotation process. Now this method is employed to purify or concentrate sulfide ore. Yes, sulfide ore, especially for the sulfide ore. This method uses different ingredients, or I will say different parts are there in this method. The first is, let me write it. The first is water. Water is used, then pine oil or pine oil is used to produce a foam. When the, as the name is froth flotation process, so we need to generate some foam. So pine oil are used to produce foam, and it also work as collector, or I can say transforming agent. Now coming to the C is cresols. Now what are cresols? Cresols are also called aniline, and it is used to stabilize the foam. Whatever foam is generating because of pine oil, cresol helps in stabilizing that foam. Okay, now coming to next is xanthate. Now xanthates, commonly employed xanthate is potassium ethyl xanthate. Okay, and potassium xanthate formula is C2H5O C double bond S negative K positive. So this is the formula. You need not to remember the formula, but I'm just telling you that xanthite is used or is employed in this process as collector, okay, to increase the wetting of the sulfide ore. Now coming to the next is depressants. Now depressants and activators to collect the required sulfide part from the ore. So whatever sulfide part or part we are getting, depressants are used to collect the required sulfide part. For example, examples of depressant I can give you as galena, which contains a good quality of zinc sulfide with lead sulfide. Now NaCN, which is sodium cyanide, is used to convert most of the zinc sulfide into water soluble complexes. Now what happened in this? The powder ore is put in a tank, as you can see here. The powder ore is first put in the tank containing a stirrer, a device of passing compressed air, and all the above material which I just discussed are used. Okay, now foam is produced by wetting and lifting of sulfide ore. So two steps are important: wetting of sulfide ore first, and then lifting of sulfide ore to the surface. Now it is washed with the water to collect the ore. After at the end, what is happening? It is washed with the help of water and collecting the ore. Okay. So now coming to the next is leaching method. Now leaching method, it is a method of collecting the required metal from an ore in the form of aqueous solution of its selected compound by treating the ore with acid or base or some other reagents. Now here in front of you the example is the Bayer's process. You all might have heard about the Bayer's process. In this process, bauxite is used. So in Bayer's process, for red bauxite, the ore is continuously stirred with 45% of NaOH with 45% of sodium hydroxide at a temperature of 200 degrees Celsius to 250 degrees Celsius to collect the solution of sodium meta-aluminate. Now what is the formula of sodium meta-aluminate? The formula is NaAlO2. Sodium meta-aluminate. It is then diluted and kept with aluminium hydroxides for about 36 hours at 25 to 50 degrees Celsius to convert it into aluminium hydroxide, which is again a PPT form. Okay, PPT means precipitate form. And ignition temperature of aluminium hydroxide is 1200 and at this it produces aluminate. At 1200 degrees Celsius it produces aluminate, which is Al2O3. So the part 1 is up to here only where we discussed different methods like pulverization, magnetic separation, hydraulic washing, froth flotation process and leaching. Now in the next part we will discuss that how we can convert ore to its oxide form. Now again for that we have two ways, calcination and roasting. So let us discuss that also in this part only. So conversion of ore to oxide form can be done by roasting and calcination. Okay, now what is roasting and what is calcination? Yes, when the sulfides ore are generally roasted in the furnace in free supply of air below melting point, this is called the process where this zinc blend I will say, the ore changes to its oxide form. Okay, especially this is done for the zinc blend and the and other metals also which are in sulfide, which are present in sulfide ore. So as you can see here on the screen, roasting ore is heated in excess of air, whereas in calcination ore is heated in the absence or limited supply of air. Now this is roasting is used for sulfide ore and the calcination is used for carbonate ore. SO2 is produced along with metal oxide and CO2 is produced in calcination along with the metal oxide. So in the next session we'll see how we can reduce the oxide to different metals by using different methods, and also we'll learn about the Ellingham diagram, which is very important. So for now, bye bye and wait for the next video.